So in this video, I am explaining the concept of the Butterworth filter. So here I classified this Butterworth filter in different process to understand the things regarding this Butterworth filter. The first one is origin. So origin means history. So how or when it was invented, and second one is knowledge level. In this I explain the formula of existing Butterworth filter, and also I am giving an explanation on the Butterworth filter, how it is formed. Next, third one is calculations or analysis. So in this calculations part, I am going to introduce, or I am going to explain how to calculate the order of the filter and all. And in the last one is fourth one, it's a evaluation level. So this is the important level of this video, because it is very helpful for the research holders or those high level students. So that means once they knows the concept of the Butterworth filter, then the students or researchers can do the further research based on these evaluation points. Okay, coming to the first point, origin. So in this, the Butterworth Stephen, his name is Stephen Butterworth. He was introduced in 1930, whose paper title under the title as On the Theory of Filter Amplifiers. So in the first paper, the first edition or the first paper or first invention of the Butterworth formula as like this: G of omega is equals to 1 by root over 1 plus omega 2n, or we can call it as, we can write it as G of analog frequency. This value omega is equals to 1 by root over 1 plus this omega whole power 2n, or we can write in the analog form as G of s is equals to 1 by root over 1 plus s by j whole power 2n. This is the standard form. This has introduced in 1930 by Stephen Butterworth. And next topic of this video is explanation knowledge level. Explanation of knowledge level. So already we have seen that this formula is the Butterworth formula, where n is equal to 1 comma 2 comma 3, and we can rewrite this as a normalized Butterworth filter. Butterworth formula is h of j omega is equals to 1 by root over 1 plus omega of 2 power n, or it can be normalized. That means in terms of analog frequency, analog or Laplace transform as 1 by root over 1 plus s by j whole power 2n. Here this h of j omega is equal to 1 by root over 1 plus minus 1, because here the j square is equals to 2 power j square is equals to minus 1. Here we can see it, we can observe this j square is equals to minus 1. So from this we can rewrite this formula as 1 by root over 1 plus minus 1 whole power n s power 2n. This is the whole formula in different modes. And next, coming to the calculation of poles. So here h of s is equals to 1 by, see this formula is like this, and here normalizing, that means this is the, we want, when we are going to find the calculation of the transfer function is, first we need to find the poles of the transfer function. So how to find the poles of the transfer function? This is the numerator and this is the denominator. Once your denominator equals to 0, then from that we can find the values of the poles. So here this denominator is like, this function is equals to 0. See, 1 plus minus whole power n s power 2n is equals to 0. Then this is for calculation of poles. So 1 plus, so see, this equation is equals to 0. So from this we can rewrite this equation as minus 1 power n s power 2 is equal to minus 1. So here this is, here the n is a variable function, that to minus 1 power n. So that function, this function is leads to different ways. If n is equals to odd number, this leads to one way, and n is equal to even number, this leads to another way. First you calculate into first order. If n is equals to odd, that means n is equal to odd means this becomes minus, odd means minus 1 is always along with this equation. So minus 1 here gets cancelled. So here s power Okay, where here the variable function, we can write this as a variable function, s of k 2 power n is equals to 1. So now here the 1 can be written as, that means we can write this as cos 90, so sin 90 and like that, or cos 0. So h of this is the function, and apply log both sides. So once you apply log both sides, that is 10 log of this function is equals to 10 log of this, 10 log of 1 by root over 1 plus epsilon square omega by omega p whole power 2. So based on these calculations, a simple mathematics, simple apply log and anti-log, then finally we are going to find at omega is equal to omega p, the passband attenuation minus alpha p. So minus alpha, substitute minus alpha p is equal to 10 log of 1 plus epsilon square omega by pi by omega pi by 2n. These two gets cancelled. This becomes minus alpha p is equal to minus 10 log of 1 plus epsilon square. So from this we can calculate the value of epsilon square. Very simple. Thus, and apply anti-log 1. Thus finally we achieved epsilon, that constant variable value which has been introduced in the formula, epsilon is equal to 10 root over 10 power 0.1 alpha p minus 1. And at the same, for the same way we substitute or we calculate for stop band at omega is equal to omega stop band frequency. Gain is minus alpha. Already we, as we seen in the diagram, graphical diagram of the Butterworth. Thus same apply for the same 20 log of this is equal to 10 log minus. So this all we can see, same we can observe very easily in a simple mathematics methodologies. And finally see, finally this value is equal to this, finally n is equals to log of 10 power 0.1 alpha s minus 1 divided by 10 power minus 0.1 alpha p minus 1 divided by log of omega s by omega p. So once order, how to calculate this order, by giving the value of passband attenuation, so stop band attenuation and passband attenuation, and stop band cutoff frequency and passband cutoff frequencies. Once these values are given, then we can easily find the value of order n. Okay, and this is the final conclusion of this Butterworth filter, and it's very important for researchers or those who are interested to do further research work. Already first point, in this first point, h of j omega is equal to 1 by root over 1 plus epsilon square omega by omega p whole power 2n. This is the formula. Instead of above the formula, so we can write, already we introduced this epsilon value in denominator. So why can't we do the introduce a constant factor or variable factor in the numerator? So based on this, h of omega j omega is equal to a by 1 plus root over means root over 1 plus omega p whole power 2n. So to calculate the order, so already initially we have introduced this parameter and calculate order as we have seen in the previous discussion. But once you substitute this a introduced in the numerator, and to calculate the order n, at same steps have been are supposed to be repeated, that omega is equal to omega p, calculate a, and next is, and omega is equal to omega is calculate order n. So this is the one way or one procedure to calculate order of the n. This is the first point. And the second point is important point is, since whether in the first method or the second method calculation of order, but finally the order value here, the order value may not be an integer, it may be a real value or integer value. Suppose for example n is equal to 2.73, for example we could attain 2.73, that means the power of the filter is s power 2.73. So now we can write this is s power 2 plus 0.73, and similarly the s power 2.73 can be rewritten as s square into s power 0.73. So first we calculate this, and the second we calculate this integer methodologies, by using integer methodologies. Once this calculation is completed for this order 0.73 and the 0.2. Then after final transfer functions have been derived, then we can multiply them. Then finally it reaches to 2.73 is the final answer. But instead of doing in the fundamental conventional methodology, if the value is 2.73, then that means we round off to nearest integer. That means based on the alpha s, alpha p, omega p, if we attain 2.73 is the order, then we have we